Okay, morning everybody. Okay, today will be in our last topic for physics for Set 4 O-level physics. It will be the magnetism and electromagnetism topic. Okay, this topic is actually quite big. It actually consists of 8 small subsections, and these topics or this content actually writes on your primary school content and your lower sec understanding of magnetism. Okay, now let's take a look. Now, these are the 8 topics that you generally you generally come across. Okay, the idea here is to understand the idea of magnets. Okay, what does the magnetism, what does magnet comprises of, or what does the magnetic field comprises of? And after that, we'll go down to the applications of the magnet. Okay, how do we use magnet to help us in our daily life and in our daily applications here? Now, for starters, okay, the first section here, we look at the magnet, the idea or the understanding of magnet. Okay, for magnet, the first thing that we need to know is what material contributes to making a magnet. Okay, the material that we're talking about are what we call the magnetic materials. Okay, not all metals or not all materials can be used to make a magnet. The material has to be magnetic in nature. So there are a dozen of materials in outside world that we can use for magnetic material, but for O levels there are 4 common materials that students need to take note of, which is iron, nickel, cobalt, and steel. These are the 4 magnetic material that we have, and you take note among these material. Okay, you'll find that our common material like copper, good conductor of heat and electricity, the best so far that we use in our daily life. You'll find that copper, surprisingly, is because of its nature, is not part of magnetic material. Okay, so students common mistake that they have is they automatically assume copper being a good conductor of electricity, being a good conductor of heat, they are automatically the best material for for magnets. Okay, so this one students you have to take note. Okay, copper is one of the things that we actually strike out here. Okay, it cannot be used for magnet. Okay, the reason later on, the reason for why it cannot be used for a magnet will be touched on later. Okay, so as a starter, okay, take note of the 4 materials, 4 metal that we think that we can use to make magnetic material. Now, in general, okay, everybody will know from primary school there's 2 poles that we are looking for, the north and south pole. There's a common understanding. And these poles, okay, usually what we see them, they are usually across maybe a bar magnet on the 2 extreme ends. Okay, the 2 extreme ends, actually, these 2 ends are what we call the strongest at the poles, the strongest at the ends. Okay, so the whole magnet, the whole bar magnet here, actually, the whole area is you have this thing, this magnetic effect, but it's actually strongest at the 2 corner where the north pole and the south pole is. Okay, and if you rest a magnet, okay, you'll find that it actually points in the north-south direction. Okay, that's where we have a most common application. They started like maybe centuries ago. The use of compass, whereby you have actually a magnet that points to the north. Okay, we also touch on the idea of compass later on under one of the applications. Okay, this is what we mentioned, a simple compass. Now, property of magnet, okay, like what we mentioned, okay, the magnet, like what you done in your primary school, okay, magnet, actually there are 2 things. Okay, it does attract or does repel. And here we have to take note that at Sec 4, when we talk about keywords of your idea, when we talk about things starting repel or the objects the objects given start to attract, okay, we have to state the reason. And the reason commonly, if it's due to magnet, when due to magnetism, the keywords that we always like students to use, we always like to see is we always like students to use the word like poles repel. Okay, or like poles attracts. Okay, this actually tell the marker that the students know that the magnetism, the repulsion, is actually caused by the inherent property of like they having being the same pole, like north or south poles. Okay, so likewise, okay, the only thing that you have to take note is like pole usually mean north and north or south and south. This is quite standard. Okay, for unlike pole, you have to take note there are 2 possible situations. Okay, for example, if you look at light pole, you'll find that these 2 situations, they are all magnets. Okay, they are definitely, the 2 materials definitely have to be a magnets. But the problem is for unlike pole, for them to be attracted, the keywords here is attraction. Okay, key like pole and unlike pole. So for unlike pole to attract, one of the possible cases that you have actually 2 magnet, which is unlike pole. One is north pole, one is south pole. Okay, so you literally have 2 magnet, which is unlike pole, which is opposite pole. They will have attraction. But there's another category or another situation whereby you look at attraction. Attraction, it could be one side is magnet, the other side could be a magnetic material. So if you have a magnetic material, it need not be a magnet. It could be an iron bar, okay, or steel nails, okay, or a steel bar. Okay, it's not magnetic, it's not a magnet yet, but it is a magnetic material, which means it can be attracted or it can be made into a magnet later on. But as for now, it's just a piece of metal. Okay, so I have a magnet, I have a magnetic material, let's say steel. Okay, if I move the magnet close to it, it literally, because it's being magnetic material, it will actually fly to the magnet itself. So this is what we call attraction. So when we have attraction, there are two possible cases. The second scenario students have to take note is I can have a magnet here. It can be north or south, okay? And I have a magnetic material. So it will still cause attraction. So underlining here, you have to take note is that because of these two properties, okay, these two situations, when we talk about identifying magnets, okay, you have to take note of what are the possible tests that we look at. Example, do you use an attraction test or do you do a repulsion test? For example, if I'm looking for material A attracting material B, it is safe to say that because of attraction, these two are actually magnets itself. Okay, for example, here we can straight away saying that the attraction here that we look at, okay, the attraction here, okay, the two magnets are attracted, we can actually conclude that either one of them is a magnet, okay, either one of them, only either one, okay, because there is actually two cases, okay, it can be either, first case can be A and B, they are actually both magnet. Example, it could be case one, it could be both, one is north pole, one is south pole, okay, so they can attract each other, okay. The other possible case that I'm looking at is it could be one of them is a magnet and the other guy could be a metal, okay, and metal B is, okay, a magnetic material. So I can have maybe A is a magnet, which is a north pole here. I can have a maybe iron bar. Okay, so I cannot actually conclude which metal is actually magnet. But it could be a case whereby magnet B is metal B is actually a magnet. Metal A is a magnetic material. It will still, both of them will still attract one. Okay, so when we talk about identifying magnets, the test that you need to take a look is you have to take note of repulsions. Okay, how do we test two magnets being a repulsion? We have to make sure that the two magnets actually moves away from each other, or what we call repel. Okay, because what the keywords that we are writing on here is, remember, is like poles. Sorry. Okay, so the keywords that we are writing on here is like poles repel. Okay, so this is one of the keywords that we actually like students to use. Okay, so like poles, okay, repel. Okay, and when we find the two of them repelling, I can safely say that both of them is definitely same pole, north north or south south. Okay, and because of that, I will know that both metal A and metal B are actually magnets themselves. And because of that, I can actually conclude A and B are magnet of a certain pole or whatever pole is at which corner. Okay, so take note of these things that we are looking out for. Okay, so in loosely saying, okay, in a nutshell, the test that you need to take note is when you look at the keywords like unlike pole attracts, like pole repels. Okay, when we look at these keywords, how are we going to use it other than keywords? We actually use it as a test. Okay, but what we call a repulsion test. You have to take note of the repulsion test, okay, which is the one that you see on your right, okay, of the screen. Okay, this is the repulsion test that we are looking for. Okay, when we identify a magnet itself. Okay, now the other property that we look at magnet is its ability to induce magnetism on other material. For example, like I mentioned before, when I have a magnet, okay, and a magnetic material, this is a magnetic material. So example, like in the first slide that you see, in the first video that you see, it could be example iron, or it could be a steel bar, just a steel bar by itself. Okay, but what happened now is when I move the magnet near the steel bar was just a normal bar. Okay, it's not not magnetized. But what happened when I actually put the magnet near it? When I put the magnet near it, you will find that we have this attraction force ongoing. Why? Because when I actually put the magnet near to the steel bar, okay, the steel bar or the iron bar, whichever bar magnetic material you use, it will be induced a magnet, which means that I will actually induce a pole. This is what I mean by induce. Okay, temporarily I bestow the ability for magnetism, so I'm inducing a south pole. Why is it a south pole? Because why is it a south pole? Because I know magnet and magnetic material, they will attract. Okay, unlike pole attract. So one of the keyword that we have is because it's unlike pole. because it will attract. So I definitely know that because I have a north pole here, which is a permanent north pole, I will actually induce a south pole to be formed on the magnetic, on the steel bar here, or maybe iron bar here. I would say it's temporarily, I temporarily bestow that particular pole onto that metal bar. And because of that, now, because I have a south pole, I have an induced south pole on that steel bar or iron bar now. And because of that, I have a south pole on one end, I will have a north pole on the other end, because north and south pole, they occur in pairs. And because of that, now my bar has actually possessed induced magnetism. Okay, induced means is given by another people, and it's given, it is actually, it has that, it pick up the magnetism effect because of a magnet nearby. Okay, and this is what we call induced, okay, indirect. And because of that, the induced bar is able to attract the paper clips. And same thing, the paper clip usually is like a magnetic material again, because I know it has to be a magnetic material because it will be attracted to the magnet. Meaning, same as the magnet, because now this, same as the previous case whereby the magnet induce a magnetism on this iron bar or steel bar. So now what happened is this iron bar, which serves as a magnet now, will actually induce magnetism onto the paper clip. Okay, similarly to what it has happened before. So between a north pole here, I will induce a south pole here, okay, onto the paper clip. And because north and south, they are unlike pole, they will attract each other. So that's why I know that magnetic material will always attract to the magnet itself, because the pole that you induce is always the opposite pole, and unlike pole, they will attract. And this is what we mean by magnetic induction, okay, which the ability for a magnet to induce magnetism onto another magnetic material, okay, with near or in contact with that material, okay. Or what we call in layman terms is the ability for me to actually spread out my magnetic effect. With the ability from one magnet, I can actually create a second magnet. So-called, I can actually increase my area of influence. This is what we mean by magnetic inductions. Okay, the layman terms are. Okay, so similarly, if I can do it for one paper clip, I can actually do it for the other two paper clip. For example, this. Okay, now I have a piece of magnet here, and I have a piece of wood. Now, wood is, remember, is a non-magnetic material. Non-magnetic material. Okay, it's non-magnetic materials. But what happened is the wood will actually, I would say, it will actually partially reduce the magnetic effect. Okay, but it cannot totally cut off the magnetic effect. I mean, the magnetic effect will still bleed over, will still pass through the wood, and it will still arrive at the paper clip here. So which means that same as before, because of this magnet, okay, and this is magnetic material, it could be an iron paper clip, or it could be a steel bar paper clip. Okay, so it are magnetic material. So what happened is now that I have a north pole here, I will actually induce a south pole on this end. I will induce a south pole on this end. Why? Because unlike pole, they will attract. Unlike pole, they will attract. Okay, and because of that, okay, and because of this, okay, the induction, I am able to hold the paper clips to the wood itself, because the paper clip is attracted to the magnet itself, okay, through induction. So I can actually attract it by inducing a south pole on the end of the paper clips. Okay, so that's what we mean by induction. I can actually induce a magnetism. And because now I have a south pole here on this end and on this end, automatically I will have a north pole at this end, a north pole induced at this end. Remember, north and south, they always occur together. So if I have a north pole on this end, I will have a south pole on the other end, because north and south, they occur in pair. Okay, so now because I have a north, okay, you'll find that, the because they are north pole, or aka should I say they are like poles, okay, they will actually repel each other. So that's why from the picture you'll know that the paper clip, instead of two paper clip actually hanging down straight down, you find that the two paper clip will actually shift away. Okay, why I shift away? Because the bottom side here is actually the same pole, north. So north and north, because they are like pole, they will actually repel each other. By right, the south pole at the top corner, they should actually repel each other, but they are not able to do that because this south pole is attracted to the magnet, which is on top of it, which is the north pole here. So they are attracted to it. So the attraction force is actually stronger than the repulsion force at the top end. Okay, but At the bottom end, the North Pole and North Pole, they are actually the repulsion is actually stronger than attraction. So you'll find that at the bottom end, you'll find that two paper clips will actually slant from each other because of like pole repel. Okay, and with this, we actually cover the first two sections of whereby we talk about the material, the type of magnetic material that students need to remember, the types of magnetic material. Okay, so there are four of them. Okay, so students, you need to take note of which are the four materials. And with that, we also cover a bit on the common problem that we have, which is copper. Okay, copper is not a magnetic material. Okay, and it's one of the things that we students have to take note. Okay, when we talk about using, when the question, whether the question uses magnet versus magnet trying to attract maybe a copper bar, magnet attracting an iron bar. Okay, to see whether it can attract or don't attract. Remember, copper is non-magnetic material. It cannot be attracted by a magnet. After that, we look at the keywords, whereby the keywords, there are two of them. Okay, it's fairly straightforward. It's light poles. Okay, they'll repel. Okay, so you need to identify what are the light poles. And after that, we have the second keyword, which is unlike poles. Unlike poles attracts. Okay, but here, like I mentioned before, students have to take note when we talk about attraction. Okay, attraction, like the keywords mentioned, it can be unlike pole, north and south. Okay, interchangeable. Okay, or I can actually have a north pole and a magnetic material. Okay, I will still be able to attract. So when we talk about attraction, students, you have to be careful of the common thing. When the question says it's an attraction by two magnets, by two material, you have to be careful the attraction. It could be two unlike poles, magnet and north pole and south pole, or could it be one of them is a magnet and the other guy is the other metal, the other material could be a magnetic material, it's just a metal. Iron, steel bar, copper, or this iron, steel bar, and maybe cobalt. Okay, so it could be a case whereby one of them is only a magnet, the other one is a magnetic material. Okay, so with this, I have come to the end of the first two sections here. Okay, I hope it's quite it is quite clear. I have not like make it too confusing. Okay, if you have any problems or any questions, okay, feel free to leave your question at the comments bar, so I will get back to you ASAP. Okay, if not, okay, remember to subscribe to my channel to get an update of what topics I'm going through and what are new videos that it could be of interest to you. Okay, with that, okay, this is where I end off, and I will see you in the next topic. Thank you.